So I'm back at the stairs outside Mr. Robinson's room for where I did my Eiffel Tower challenge yesterday. I'm going to now set you some maths questions, challenge questions, see can anyone answer them. I brought out rulers and protractors. I'm going to take some measurements and I'm going to set some questions. Okay, so it's time for some of the maths for this Eiffel Tower at-home challenge. What is the angle of elevation of each step? So if you're near 7 and 8, you may need to research that. It's from Trigonemetry, but it's basically just reading the protractor. Part B then, what is the length of one shoe? So I've used shoes to measure some of this challenge, so you need to know the length of one shoe. You can criticize my accuracy later on. Question 2. Estimate the distance covered in the stair climb challenge. Seems quite easy, but I'm talking about my literal distance as if I was running up a mountain. No, we're not looking at the vertical distance. That should be 324. We'll come to that in a minute. We're not looking at the horizontal distance either. We are looking at this diagonal distance, or the hypotenuse of a right angle triangle, looking at that distance. Now there's a lot of inaccuracies here that you may need to come into. It's not as simple as that. For instance, there's actually 2 staircases separated by that little patch in the middle, which I measured with my shoe. Also the bit at the start I measured with my shoe. There's no right answer here, but there are going to be some close estimations using trigonometry. With right angles to triangles such as these, you're going to have to use some trigonometry to work out what my distance covered in the entire challenge was. Okay, so remember I did 100 of those flights of stairs, 20 steps in each. Question 3. I plan to climb 324 meters vertically. How far do you think I climbed? So I planned, maybe I didn't. I did 100 flights of stairs, not the 97 I was planning on doing. So how far do you think that was vertically? So I'm looking for this up. You may need to use trigonometry again, or you can use your estimation skills, or you can just use those measurement skills. And you may notice that each step wasn't the same. So you may have to think about that. Calculate some sort of percentage error. So once you've figured out how far you think I climbed, I wanted to climb 324 meters, so maybe you can find out a percentage error. You may need to look up the percentage error formula for that. You may need to find out what the error was. Question 4. What was my average speed and velocity? So my speed, well, you can break it up in a number of ways. You can talk about horizontal speed, vertical speed, or you just do overall speed diagonally. So that is up to you how you want to interpret that question. Simple speed, of course, is distance divided by time. So you have my time, so there. Make sure you convert it to the right unit. Perhaps you want to do kilometers per hour, or meters per second. Up to you. It might be interesting to have a number of different representations of that speed. question 5, criticize my accuracy. Okay, so there's lots of issues with this stair climb challenge. You need to find out as many as you can. Criticize me and my methods as much as you want, but back them up with some facts, mathematical facts if you can. Maybe some research, maybe some calculations. You may need to draw a diagram for some of these when you're handing in your answers, especially those right angled triangles in questions 2 and 3. Okay, good luck with it. So you've got your 5 questions for the Eiffel Tower problem. There's another 5 at another stage, but we start off with these 5. Think about how you present your work when you present this. In maths, it's important that we logically lay out our work. If you have a point to make, back it up with calculations, diagrams, research, tables, graphs, something like that, and then discuss afterwards. For instance, there's no point in saying that something is very accurate or very inaccurate. They are not very precise mathematical terms. You could back things up with percentage errors and then make a statement after that. So that might be one way of going for those particular questions that ask you to discuss. For those older students, years 10, 11, 12, you guys will be doing IEs at some stage for a diploma program. And when you get to the end of year 12 and start of year 13, this is very similar to the kind of discussions you may need to have regarding limitations and accuracy issues of your models that you create. So you may create some sort of functional model, and you may have to delve into the accuracy issues. Perhaps more simplistic in my stair climb, but definitely some of the language you can use and some of the methods you use, you can apply here. So you can try and figure out where you can look at those limitations of my work and of your work due to my lack of information I gave you. If you have any questions, more than welcome to email me on any of this. Let's see who creates some interesting answers. Delve into it as much as you can, especially maybe if you're in the younger years and you haven't done trigonometry yet. Maybe you can research trigonometry. There's no reason why you wouldn't be able to do some of it or all of it. For instance, trigonometric ratios, sine, cos and tan, all those things you see on the calculator, you're going to get to them at some stage, so why not learn them a year early? You guys in year 9, 10, 11, 12, 13, you should be well familiar with trigonometric ratios at this stage and how to apply them in this particular problem. If you're not, maybe you can ask your maths teacher over the next couple of weeks how to do it. Okay, so good luck with this challenge, and hopefully we see some interesting and detailed answers to this problem.